In the early hours of a classified mission, an American pilot sat alone inside the cockpit of an SR-71 Blackbird, high above hostile territory, watching as warning lights flickered across his instrument panel. Far below him, Soviet radar stations had already locked onto his position. Inside those command centers, alarms were sounding, operators were shouting coordinates, and missile crews were preparing for launch. Within minutes, surface-to-air missiles would be racing upward, guided by radar, designed to intercept anything that dared enter their airspace. But inside the cockpit, there was no panic. The pilot had been trained for this exact moment. He understood something the men on the ground were only beginning to realize. They could see him, but they could not stop him.
As the first missile launched, the aircraft's warning systems registered the threat almost instantly. A sharp tone echoed in the pilot's headset, indicating tracking and engagement. The missile was climbing fast, accelerating through the atmosphere with deadly precision. In most aircraft, this would be the moment for evasive maneuvers, sharp turns, or defensive countermeasures. But the SR-71 was not like other aircraft. Instead of diving or turning, the pilot calmly advanced the throttles. The engines responded with controlled power, pushing the aircraft even faster. At speeds exceeding Mach 3, the Blackbird didn't try to outmaneuver threats. It simply outran them.
The Cold War had transformed the skies into one of the most dangerous domains on Earth. Reconnaissance missions over enemy territory were essential for gathering intelligence, but they carried enormous risk. Earlier aircraft, such as the Lockheed U-2, had already proven both the value and the vulnerability of high-altitude surveillance. When a U-2 was shot down over Soviet territory in 1960, it became clear that altitude alone was no longer enough to guarantee safety. The United States needed something faster, something that could operate beyond the reach of evolving air defense systems. The answer would come in the form of an aircraft that pushed the limits of engineering and physics.
The development of the SR-71 Blackbird was unlike anything attempted before. Designed in secrecy by Lockheed's Skunk Works division under the leadership of Clarence Kelly Johnson, the aircraft was built to achieve extreme speed and altitude while maintaining structural integrity under intense thermal stress. At Mach 3, friction with the air would heat the aircraft's surface to temperatures capable of warping conventional materials. To withstand this, engineers turned to titanium, a metal that was difficult to work with but capable of enduring the conditions the Blackbird would face. In a twist of Cold War irony, much of the titanium used in its construction was sourced indirectly from the Soviet Union itself.
Flying the SR-71 was as much about managing the machine as it was about piloting it. The cockpit environment was highly specialized, requiring pilots to wear pressure suits similar to those used by astronauts. At operational altitudes exceeding 80,000 feet, the margin for error was extremely small. A sudden loss of pressure or system failure could be catastrophic. Every mission demanded precision, discipline, and a deep understanding of the aircraft's unique characteristics. Pilots were not simply flying, they were operating one of the most advanced machines ever created under conditions that pushed human limits.
One of the most remarkable aspects of the Blackbird was its propulsion system. Its engines, known as J-58 turbojets, were designed to function efficiently at extreme speeds, effectively transitioning characteristics between traditional jet engines and ramjet behavior. At high velocities, a significant portion of the thrust was generated not just by combustion, but by the management of airflow through the engine. This allowed the aircraft to sustain speeds that would be unattainable for conventional designs. The result was a machine that thrived in the very conditions that would destroy other aircraft.
Despite its incredible performance, the SR-71 was not invisible. Soviet radar systems could detect it, track its general position, and even attempt to predict its path. Missile batteries would often be activated when the aircraft entered certain regions, launching interceptors in an effort to bring it down. However, Hitting a target moving at such extreme speed and altitude proved extraordinarily difficult. By the time a missile reached the altitude where the Blackbird had been detected, the aircraft was already far ahead of the predicted intercept point. The physics of the situation worked in favor of the aircraft, turning speed into its primary defense. There were numerous documented instances where missiles were launched against SR-71 missions, particularly over heavily defended regions. Pilots would receive warnings indicating radar lock and missile launches, yet in most cases they did not need to take evasive action. Standard procedure often involved simply accelerating, allowing the aircraft to outrun the threat. This created a unique dynamic in aerial operations. Instead of engaging in traditional dogfighting or evasive maneuvers, the Blackbird operated with a form of passive dominance, relying on its performance envelope to neutralize threats before they could become effective. Beyond its speed, the SR-71 carried sophisticated reconnaissance equipment, capable of capturing high-resolution imagery and electronic intelligence across vast areas. Its sensors allowed it to monitor missile installations, military movements, and strategic infrastructure from altitudes and distances that minimized risk. This intelligence was critical during the Cold War, providing decision-makers with accurate and timely information about adversary capabilities and intentions. In an era defined by uncertainty and suspicion, reliable intelligence played a key role in preventing miscalculations that could escalate into conflict. The psychological impact of the Blackbird's missions extended far beyond the technical challenge it posed. For Soviet defense forces, the knowledge that an American aircraft could enter their airspace, be detected, and still remain untouchable was deeply frustrating. It highlighted the limitations of their defensive systems and reinforced the perception of a technological gap. Even when detection systems functioned as intended, the inability to successfully intercept the aircraft created a sense of vulnerability that could not be easily resolved. At the same time, the existence of the SR-71 influenced broader strategic thinking. It demonstrated that speed and altitude could be used not just for reconnaissance, but as a means of redefining survivability in contested environments. This concept would later influence the development of other advanced aircraft and reconnaissance platforms, as well as the growing emphasis on stealth technology. While stealth would eventually become a dominant approach, the Blackbird represented a different philosophy, one where invisibility was achieved through speed rather than radar evasion. Operationally, SR-71 missions were conducted with careful planning and coordination. Flight paths were designed to maximize intelligence collection while minimizing exposure to potential threats. Refueling operations were essential, as the aircraft consumed large amounts of fuel at high speeds. Specialized tanker aircraft would rendezvous with the Blackbird before and after missions, often under equally controlled conditions. Every aspect of the operation required precision, from timing to navigation, ensuring that the aircraft could complete its objectives without unnecessary risk. The crews who flew the SR-71 were among the most highly trained personnel in the United States Air Force. They operated in two-person teams, consisting of a pilot and a reconnaissance systems officer. Communication between the two was critical as they managed navigation, sensor operation, and threat awareness simultaneously. Their missions demanded not only technical skill, but also the ability to remain composed under pressure, knowing that they were operating deep within contested airspace with limited options for escape. Despite its success, the SR-71 program faced challenges, including high operational costs and the complexity of maintaining such an advanced aircraft. Each mission required extensive preparation, and the aircraft itself demanded specialized support and infrastructure. Over time, advancements in satellite technology began to provide alternative means of reconnaissance, reducing the reliance on manned high-speed aircraft. Eventually, these factors contributed to the decision to retire the Blackbird from active service. Even after its retirement, the legacy of the SR-71 remained significant.
It continues to be studied as an example of engineering excellence and strategic innovation. Its records for speed and altitude in operational aircraft have yet to be surpassed, and its design principles continue to influence modern aerospace development. More importantly, it represents a moment in history when technological ambition pushed the boundaries of what was possible.
Looking back, the SR-71 Blackbird was more than just a reconnaissance aircraft. It was a symbol of a particular approach to problem solving during the Cold War, one that emphasized pushing beyond conventional limits to achieve strategic advantage. It operated in an environment where failure could have serious consequences, yet it consistently demonstrated reliability and effectiveness under extreme conditions.
The story of the Blackbird also reflects the broader dynamics of the Cold War, where competition between superpowers drove rapid advancements in science and technology. Each side sought to outpace the other, not only in terms of military capability, but in innovation and engineering. The SR-71 stands as one of the clearest examples of this competition, embodying the intersection of necessity, ingenuity, and ambition.
In the end, what made the SR-71 truly remarkable was not just its speed or altitude, but the way it changed expectations. It proved that an aircraft could operate in environments once considered unreachable, perform missions once deemed too dangerous, and do so repeatedly without being brought down. It transformed the concept of aerial reconnaissance from a high-risk endeavor into a demonstration of controlled superiority.
And perhaps most importantly, it left behind a legacy defined by a simple but powerful reality. In a time when being seen often meant being targeted, the SR-71 Blackbird proved that sometimes the greatest advantage was not in hiding, but in being so fast that nothing could ever catch you.